Welcome to part 2 of my van build series. My name's Rob, and in this episode I want to get the off-grid electrical system installed and operational. So why then am I still sitting here at the computer? Well, it's because I need somewhere to put said electrical system, and I want to do that inside a sofa that also pulls out into a bed. So we just need to design and build that first. You will remember the photogrammetry model I made in part 1 of this series? Well, I've updated that with the new additions we made to the van last time, so now I've got a digital copy of what exists in real life. This is a really useful tool because as I'm designing things inside the van, I can hopefully make my mistakes here in the digital world where it's a lot easier to fix. The sofa bed structure is going to have 3 bays separated by these vertical supports, and I'm thinking I'll mount the electrical system in the bottom and then make drawers above for storage. I pre-ordered all the electrical components for this system and off camera quickly modeled up their dimensions, so now I can arrange them and see how much room they're going to take up. I will get into what all of these components are later in the video, but let's just get one thing done at a time, eh? So it looks like I can fit all the components into just 2 bays. I might be able to squeeze them into one, but experience has taught me not to underestimate how much room you need for running the electrical cables. And also we need to consider the airflow between everything because we obviously don't want to overheat the components. I'm going to give the empty bay a large drawer and then put 2 shallow drawers in the other 2. Now the drawers are actually going to have double duty as both storage and support for the pull-out bed. Let me show you what I mean. So the way I'm going to do this is to have a bunch of slats where every second one pulls out to create the bed in 3 sections. Now, regular full extension drawer slides are only rated to about 40 kg per pair, which obviously isn't enough to support the weight of a couple of adults. I could go with some heavy duty drawer slides like what you see in truck bed drawers and the like, but man, have you seen the price on those suckers? Besides, I think I've got an idea for a different method. If I can pivot the drawer slide at full extension, the bottom of the drawer front can drop slightly and come in contact with the floor and act as legs supporting the weight of the extended bed, rather than that weight being cantilevered by the drawer slides. Now I don't know if this will actually work, but I think it's worth a shot. So let's get on the tools and start making some sawdust. The eagle-eyed among you may notice I've got myself a new tool. After all the cutting I did with the regular circular saw back in the last video, I figured it might be worth the investment to upgrade to a track saw. I say investment, but what I actually mean is buy the cheapest track saw available here in New Zealand. My theory when it comes to buying tools is to buy a cheap version first, then if you find yourself using it a lot, you naturally figure out what you like and dislike about it, and you can make a better choice if you need to buy the pro version. But if you end up not using the tool that much and it does the job anyway, you just saved yourself a bunch of cash to spend on another tool. But I'm pretty pleased with how this one's going so far. It's definitely better than having to set up the guides with the regular circ saw. So what you've just seen me doing is cutting out the back panel from 12mm plywood and the 4 uprights from 18mm ply. Obviously I'm trying my best to keep the weight down with my choice of ply thicknesses, but I need to consider a balance between the weight saving and the structure. And I'm just gluing and screwing the carcass together for this one. I'm going to paint this all in the end, so it's just easier to keep the joinery simple. The top stretcher fits down into the notches in the upright, and check out the wicked bend on it. That'll be okay though once it's locked in against the other pieces. Also, I made a bit of an error here. Because this stretcher is going to be bearing a lot of weight from the bed slats, I should have also notched it into the uprights at both ends as well. So I'll need to come back and glue support blocks underneath it later, but I just thought I'd call out that little mistake. So much for getting it perfect in CAD, right? Here's my full extension drawer slides, and they're 600mm long. I pre-cut a spacer out of plywood so I can mount the slides at a consistent height in reference to the floor without doing any measuring, which takes that variable out of the equation. I'd like to tell you that each of the 3 bays are exactly the same and perfectly square, but no one here is that naive, right? So I made storage sticks for the width of each of the drawers so I can reference those instead of numerical measurements when I construct the drawers. No matter how good I cut each of these pieces, they'll always be slightly different. When you're working with these kinds of DIY tools and inexpensive materials, you're probably going to have a working tolerance of a couple of millimeters. This isn't normally a problem and isn't really enough to visually see, but when it comes to fitting cabinet hardware like drawer slides and hinges and things, it can be the difference between a good fit and a poor one. So using things like storage sticks lets you work to the workpiece rather than some arbitrary numbers. I'm making these drawers from 12mm plywood all round, which should give them plenty of strength for their size. And I've been using this countersink drill bit for the plywood lately, and it's a real time saver. Remember that story I was just saying about buying cheap tools? Well, I think it's time for an upgrade on this one, but for now, I'll just have to do it the old-fashioned way by pre-drilling the hole, then changing out to a countersink bit, then driving the screws in. The inconvenience. I won't subject you to it though. I'm only screwing these drawer boxes together because I want to try disassembling them for paint and then gluing them back together fully painted. I'm just interested to see whether the ease of painting flat panels makes up for the effort of the whole disassemble reassemble thing. I don't know, I'll keep you posted on that one. I've set up this old bandsaw to cut some banding strips to cover the plywood edge of the drawers. It's not something that's really easily available in stores in New Zealand, so I figured I'd just cut some myself. So I cut a strip off, then planed the blank to remove the saw marks, then cut, then planed, then cut, then planed. You get the idea. I feel like in hindsight now, given I'm going to be painting these anyway, the amount of work here is not worth the final result in this case. Much quicker just to chuck some filler in the grain and sand it back. But at least now I know, and maybe you do too. I'm gluing the support strips into the back panel in preparation for the slats, and while that's drying, I'll turn my attention to fitting the drawer fronts. I packed them out with spacers to really stupid-proof the alignment, and then screwed them in from the... What is that noise? Oh yeah, where was I? Yeah, so I screwed the drawer fronts into the drawer boxes from the back. I mean, yeah, easy. For the bed slats, I have this piece of laminated veneer lumber which was salvaged from a construction site, and I mean like literally from the skip. Now these things are typically used as horizontal load-bearing beams, so I thought I'd have a crack at cutting them down into some bed slats, as, you know, that's basically the same idea. What I hadn't counted on though was how dense these puppies are, and about 3/4 of the way through cutting them all out, my little table saw either became possessed by a banshee, or was having a mechanical meltdown. Now, being that this saw only cost me a couple of $100 to begin with, and I've given it a hard life well beyond its warranty, I did what any reasonable person would do. Fix it. Then I finished up the last few slats, planed them all smooth, and gave them a coat of finish before bringing them into the van to assemble. Right, so just checking in, I've laid out all the slats to make sure they're kind of like good to go, that I've got enough of them, and I realised I cut them all 20mm too short. They're supposed to come to the edge of the drawer front here, not the edge of the support, which is, yeah, not great. Not great indeed, and please forgive the outburst of emotion. I was caught up in the stress of the moment. Yeah, there's no way around it though. I need to make a full set of new ones, but instead of tormenting my table saw with more LVL ripping, I just went and bought timber from the store this time. Okay, we're back on track now, and I have a cunning plan for laying out the slats. I'm putting down double-sided tape top and bottom so I can have the slats temporarily fixed down while I space them out without them sliding around on me, because I only want to screw every second slat down to the frame, but with enough clearance so that the other ones can be free to slide between them. This is the support rail for the slats that pull out, and after clamping that in place, the remaining slats get screwed down to it. At the other end, I'm going to use a runner made from an aluminium strip which gets screwed down to those pull-out slats so that they can slide over the stationary ones without wanting to tip down between them. With everything now pre-fitted, I can pull them all back off again, remove the double-sided tape, and screw the stationary slats back down. Man, it's like 2 steps forward, 1 step back here today. The support rail also needs some spacers attached to it to give it enough clearance, which again is something I missed in the CAD model. I'll show you what I mean in just a second. Hang on, let me just screw this back on. Yeah, right here. I needed clearance for the rail to slide under the ends of the stationary slats, otherwise they're kind of just existing on the same plane, which doesn't really work in the real world. Anyway, yeah, okay, well, I put the runner back on and we can give it a test. Hey, alright, that's not terrible. That evening I did the same slat mounting process with the other two sections. It was a pretty long night. Now I need to add holes for the draw pulls before I can finish the rest of the pull-out mechanism. The first one I did by drilling 2 holes and cutting between them to make a handhold, but the chance of error doing it that way, or rather the chance of inconsistency I should say, is kind of high. So I made a quick little template and used a flush trim bit on the router to do the other ones. Then I marked the pull location on the draw box and trimmed that out too. The last thing is to make the draw slides do the tilty thing. I figured the easiest way to do this was to add support blocks under each one and then remove all of the screws except the front one, so the slides could pivot upwards off the blocks. My logic is that the weight of the drawer is being supported by the blocks underneath now, so that all that one screw has to do is hold its position. There's a lot of other ways to reinforce it, but I'm just going to go with the simplest option first and we'll see how well it holds up. I also added corner brackets to the 2 shallower drawers, which will give a bit of extra support for the fronts when they're load bearing. Okay, so check this out. So I pull the drawer out while lifting up slightly, then let it drop and it becomes the leg for the bed extension. Right now that load is being split between the drawer front and the 2 screws in the drawer slide, which is bad. But once the slats are on, that load will be transferred to the top stretcher instead, which is good. Sorry, I'm trying my best to explain this, but if you're getting lost, the good news is I'm all done now, so let me just show you the whole thing. We've got our regular drawer mode, and then we've got bed mode. It's the size of a double bed when it's all out like this, which isn't super wide or anything, but most importantly for me is that my head and feet aren't being crushed between 2 walls. I was a little worried about that aluminium runner getting snagged on the seat cushions as it gets pulled in and out, so I stole a couple of sofa cushions to test it on, and while it seemed okay, I've got an idea for how to do it better. But I'll swing back to that at the end of this video because I think we should move on now and get onto installing the solar panels onto the roof. I'm going to be using 2 200 watt monocrystalline solar panels connected up in series to give me 400 watts. Because they're 2 separate panels at the moment, I need to make a frame to hold them together and add some brackets so that I can mount it to my roof rails. Each of these panels weighs about 12 kilos, so I want to make sure they're all securely bolted together because I really don't want them coming off while I'm driving. To bring the power cables that run from the back of the solar panels down into the van, I need to add a little cable entry cover, which means more holes in the van. Yay! I drilled up from the inside to start the hole off because it's easier to judge from the inside using all the ribs and stuff as reference than trying to mark it from on top of the roof where everything just kind of looks the same. I held the cover down with a single screw first so it didn't wiggle around on me while I put the other ones in. After cleaning up and coating the exposed edges, I fed the cable through. Getting the sealant around the flange was a little tricky because the cable kept wanting to slide into it, but all in all, not too bad. 5 out of 7. Also, don't forget to tighten up the cable glands. And here's what it looks like from the inside. I added a block of wood when you weren't looking so the screws had something extra to grab into as they came through the roof. I thought I'd call some reinforcement in for lifting the panel up, as dropping 20 kgs of glass and wires wasn't especially on my list of things to do today. But thanks to a little bit of pre-planning and carefully placed ladders, the panels went on without a hitch. However, I hadn't checked the bolts for the roof rail actually fit through the brackets, which of course they didn't. So I had to go around and awkwardly drill out each corner before the whole thing was bolted down. These solar panels use MC4 connectors, so I needed to crimp connections onto the cable that I'd run up from inside the van. And I just made sure I left the positive end unconnected to the panels so I didn't have a live wire dangling around inside. Before we dive into assembling the electrical system, let me just give you a brief run through just so we're all on the same page, or at least looking at the same book. To have electrical power in the van, I'm going to be bringing it in from 3 possible sources. Solar panels, obviously, the vehicle's alternator, or using an extension lead to an on-grid source like a house or a powered campsite. Without going into too much detail, each of these sources needs to be fed into a controller which regulates the electrical energy into something that can be handled and used by the system as a whole. All of these then run into a central hub which can then go out to be used by the different devices. When there's electrical energy coming in from one of these sources, that electricity will just run straight to whatever device is plugged in, say a phone charger or a laptop. And when there's excess electricity, then that can be stored in batteries for later use. Okay, that was a really simplified version. If you'd like to know more, I'll put some links in the description to some far more qualified people. But I'll talk more about my system in particular as I go, so let's get back into it. The components that need to be accessed more regularly are going to be mounted to a panel at the front of the sofa bed frame. And this will let me open the drawer fully and reach down to access stuff. But they'll be hidden from sight when not in use, which I think is kind of cool. So at the front, I'm going to be putting the distributor, battery power switch, and solar panel disconnect. I'm going to be running a 12 volt DC system, and this is the fuse box which will distribute out to all the different devices. Next to that, I'm putting the AC fuse box, which is basically a mini version of the breaker box you have in your house, and that's going to be connected up to this inverter. That takes my 12 volt DC voltage from the system and turns it into AC voltage that you'd normally have in your home. Here in New Zealand, that's going to be outputting 240 volts. I think in the States, y'all have 110 volts. And that's going to let me run regular household appliances inside the van. Next goes on the controller for the solar panels. And then the controller for charging from the van's alternator. I'm using a single 12 volt 100 amp hour lithium battery, and I purposely left extra room in there in case I need to add more batteries in the future. Next to that goes the shunt, which is used to monitor the power being used in the system, and there's also a little fuse holder for the battery as well, though I'm not quite sure where to put that yet. With everything laid out, I can mark where I need to add the holes for the cables to run through. That's a weird saying. Adding holes. I think it'd be subtract holes. Okay, don't laugh. I'm normally much better at following lines when I cut stuff out. I was just at a funny angle and I couldn't see properly. I need to get a solid chassis ground for the system, and I remembered there was a D-ring bolted to the frame of the van under the floor here, which would be perfect, if I can find it. To get a good electrical connection, the paint also needs to be stripped back to bare metal around the hole. Now everything's in place, it's time to start wiring it up. I'm starting with the thickest cables first. These ones distribute off the battery and the inverter charger and carry the highest amount of current in this system. To connect them up to the components, I need to add lugs to the ends of them using this hydraulic crimping tool, which I bought specifically for this. It compresses the brass lugs over the exposed strands of wire, making a really strong mechanical and electrical connection. Not gonna lie, this was pretty slow going. Measuring out, cutting, then crimping each end of each cable literally took me like hours. And there weren't even that many of them. I think there was like 9 of them. Not that you can tell from this terrible angle of this time lapse, but here, let me show you what's going on. Let's start at the distributor, seeing as that's the central hub of everything. The positive side goes into the battery power switch, then into a fuse, then into the battery. Then the negative side goes into the monitoring shunt and back to the negative side of the distributor bus bar. I'll put links to the specific products I used in the description, but you can see this distributor essentially has 4 channels where the power can be transferred. And the first one is being routed to the inverter charger with these positive and negative wires. The other 3 channels will route in just a minute. I'm just trying not to dump all the info on you all at once. The last 2 wires are the ground wires. We have one running off the inverter charger into the negative bus bar, and then that whole negative side of the system is bolted to that chassis ground I made with a wire running from the shunt. It's been a few days since that last shot, and you can see I've got things stuck to the wall in the background, but for the sake of staying on topic, let's just ignore that for now. Off camera, I pre-made the rest of the cables, so as I install them, I'll explain what they're all doing. Going into the second channel on the distributor is the 12 volt DC fuse board, which will take all my DC devices when we get to adding those, things like the fan, the pump, the lights, all that good stuff. But for now, I'm just leaving that empty. In the third channel, I'm adding the DC to DC charger, which is what takes the power from the van's alternator and brings it into the system. I've already run a wire from the van's starter battery to the back here, so that gets screwed in as well. The fourth channel of the distributor is being taken by, you guessed it, the solar charge controller, which moderates the voltage coming down from the solar panels on the roof. It also calls for a separate ground wire which goes from the side of the unit and is bolted down to that same chassis ground. Then I need to bring the cable from the solar panel down into the unit, but that passes through a disconnect switch first, which I'm mounting to the front so I can cut power from the solar panels when I need to. And the main system's done. The last thing is just to add a little power for the monitoring shunt and chuck all the fuses into the distributor. This little dingle I'm adding is just a Bluetooth dongle for the inverter charger, which you'll see why I need in just a sec. The last fuse to go in is for the battery, and now the whole system is done. Am I nervous about turning it on for the first time? Am I triple checking everything to procrastinate from the inevitable next step? No, but there ain't nothing to it but to do it, so let's test this sucker. Despite the underwhelming visual representation, I dare say everything is working as it should. While there's a little monitor display that I'm holding there, the real icing on the cake of this system is that everything is Bluetooth. So if everything's working, all of the systems should be showing up on my phone. Pretty cool, right? Almost as cool as spending the next 2 hours updating all of the apps and getting them talking to each other. But once I had all my settings in and I was sure everybody was going to play nice, I could test out the other systems. First, the solar panels. $8 watts? Oh, that doesn't seem right. Oh. We might have to try that again when the sun's out. However, one thing that doesn't matter if the sun's out or not is charging off the van's alternator. So this is what it looks like with the engine turned off. But if we start it up, now the controller comes to life and we can see how much power that's bringing into the system. Just so you have a reference, my big desktop PC uses around 150 to 200 watts when I'm 3D modeling. Okay, there's a bit more sun out today, so let's have another crack with the solar panels. I'm adding a 12 volt USB charger to the fuse board so I can test charging my phone. Now, if I turn the system on, we should get some off-grid charging happening. Nice. And we can see from the app that the solar panels are bringing in 150 watts at the moment, which is saying it can charge the phone forever. But let's try something a little different. I've rigged up this extension lead to plug into the inverter so I can run an appliance I know you're all familiar with. Check it out, infinite solar powered 3D printing. I don't know if you can tell, but I'm having so much fun with this build, but there's still heaps more to do, so I really hope to see you for part 3. If you'd like to help me appease the YouTube algorithm, hitting that like button really does make a difference, and it's very much appreciated. Alright, I'll see you on the next one. Bonus footage for those of you still watching. Remember the better idea for the sliding bed slats? Well, it's a bit more work, but I think this is a better way to do it.